I don't want you to get the idea that simultaneous equations is nothing. That's something you can bargain on that will definitely 100% be in a matric paper. Solve x and y. Solve x and y simultaneously or just solve for x and y. They are simultaneous equations. What does that mean? These are two graphs, of which the one in grade 11 is a straight line, a linear graph. And the other one is something quadratic, which isn't necessarily a parabola, because this is not a parabola. This is not even a circle like I showed you in the previous example. It's something that's got to be a curve, like a parabola, but it could be a cubic graph, it could be something that does squiggly wiggly things. That's beside the point. But if I want to know whatever this thing is, and it's some sort of a curve, where it cuts through this straight line, then usually there are 2 points where they intersect. Usually. But it's possible for them just to have one point of intersection, and I showed you on the previous day. Maybe, for instance, if I asked you where those two intersect, your answer would be? No solution. Not that the sum doesn't work, but there is no intersection. So what we're doing here is finding out where these two graphs intersect. The main thing, what the whole technique that I'm teaching you here and what you were taught last year is, where they intersect on a graph, what does that mean? Whether it's a straight line and a parabola or which two graphs, where they intersect, the x is the same on both the graphs. The y is the same on both the graphs, whether it's there or there. So if I then go for my substitution technique, it must make sense to you. That if I go and write either y or x alone, or y or x alone, now which is the best thing to do? The linear one. And the easier one of x and y is the y value. Will it work if you do it the other way? Yes, but there are techniques inside of quadratic and cubic and other graphs that you don't know yet. So stick to linear, get the x or y alone, put it into the other one.
Yes.
Because it's possible for me to go and get this y alone as or equally easy. Just take it to the left hand and it's positive y and take everything to the right. So if I've got that y equal to wara, and this y equal to, can I not then put those two things equal to each other? Are you with me? Because they're both equal to y. And why can I put them equal to each other? Because the two y's are the same on the place that they intersect. Not everywhere, but on the place of intersection. That's why I can put the one's y expression into the other one's y expression, because on the place where they're equal, then I will find my y values are the same. So I'm substituting for y into that equation. I'm looking for another color and I don't have one at hand. So I'm saying equation 1, equation 2. And I'm saying I'm going to take 1 and I'm going to put it into 2. And then what happens? Then this number 2 will not be x squared minus 2x equals 3 minus y. That y will now be substituted by? Do you agree it's the same as last year?
Yes.
It's a little bit more difficult because of the squares in the more difficult one of the equations, but the principle is the same. Now, out of this comes a what type of an equation? Quadratic. Last year, linear went to linear, and you got how many answers for two straight lines that intersect? Only one. There's only one possible way, possible place that two straight lines can intersect. Only on one place. Alright, so now I've just got to solve an equation which you've been doing with your eyes closed for now.
Yes.
So we have to
Substitute negative.
first time in the negative distributively, seeing that it's a quadratic equation, my rule is let it equal to 0, because then I've got x squared. Now plus 2x, minus 2x and plus 2x will become
Cancel out.
0. And then that was 1 on the right hand side becoming negative 1 on the left hand side. Are you with me? It's still a quadratic equation. Why do we do this? Because then we factorize. And if we factorize, then we can say if two things are timed and the answer is 0, one of them has to be 0. If two things are timed and the answer is 3, it doesn't mean one of them is 3. Only for 0. That's why the technique is get it equal to 0. So now I'm factorizing. Is this something that I can factorize?
Yes.
It is the
Difference of two
difference
squares.
of squares. So x minus 1, x
Plus
plus 1, and x is either 1 or
negative.
negative 1. Another technique to consider. Can't I just take that 1 across and say x squared is 1? But maybe just say don't put it equal to 0.
Yes.
Okay, but if I do that, because there's only one variable, the moment that there's two, I'm not going to do what I just did there now. The moment that there's just one variable, just use the principle of get it alone. How do I get that x
You
alone?
root and then
By
plus
square
minus
rooting
1.
it, and then you must write.
Plus minus 1.
Now the square root of 1 is 1. Now you still got the same answer as I just did with my factors. But say for instance this was a 2. It's not, but if it was a 2, then this technique was the only available option for you. Otherwise you'd have, no it's not. Otherwise you'd have to go for the formula, because it doesn't have factors. And that's the rules. If you can have factors, then you go and factorize. If it can't, you go for the formula. But there's another option. Take it across and the answer will be square root of 2 plus and minus. You have to have all of the options available so you can apply them. Alright, let's just make this correct. And I'm finished.
No,
Why not?
you still need to look for y.
Alright, they cut on a place where there's an x and a y. I've only got the x. Now you've got to go back where?
Substitute.
Which one?
No y.
Anyone, but please go for the easier one. Don't make your life as difficult as possible. So we've got into number 1, we've got y is equal to 2 times x plus 2, and the x value is
Y.
1, and the other one?
Negative y.
Negative 1. But for both of them, it has to be substituted. In either one, please choose the easier one.
Yes, ma'am.
So that the answer is 2 plus 2 is 4, and the answer is minus 2 plus 2 is 0. So if you want, you don't have to. The question said solve for x and y. There are my two x's, plus 1, minus 1. The two y's are 4 and 0. Where is the point of intersection, in other words? Not necessary that you write them, but what is the point of intersection? Together with the plus 1, it's a 4. And together with a minus 1?
0.
So on this graph, if you have to go sketch it, you have to know exactly where those 2 points are now. Without sketching it, I know exactly where they're going to intersect. Are you with me?
Yes, ma'am.
So I showed you the example, I gave you 2 homework sums, and that's going to be it. Are you with me? Not because it's not important, it's because that's it. Whether you go do it 30 now on your own, which you should, and maybe see some little more difficult stuff, it's going to be good that you do that, but I'm not going to do 20 more of them and spend 3 days on that. Okay, so for this one, what's the option?
Use the linear graph.
Which one?
3x minus y equals to 2.
Take the y to the right hand side, I like it. Okay, and then on the left hand side you'll have 3x minus
2.
Or keep it on the left, it's not a problem, but then most kids just leave it as y and take the 3 across, and it's 2 minus 3x. They make an error with those signs. So just be careful. Doesn't matter which way you do it. So again now, I didn't do anything to the right hand side, just leave it. I'm going to say I'm going to put 1 into 2. Does it have to be the linear one on the left and the more difficult quadratic-ish one on the right?
No.
Because I could put this one on the left and then that one on the right. You're still going to look for the linear one, get the x or y alone. Will it always be able to not have fractions? Say this was, for instance, 4y or 6 or 5y. Then, unfortunately, you are going to, whether you take the x alone or the y alone, you're going to have fractions. Unfortunately, that makes it a little bit more difficult. But you're still going to go for the linear one. Alright, whether it's fractions or not. Then it becomes a little bit more difficult because now into the y or the x I've got to put fraction-ish things. But you can work with fractions. We're going to look at fractions now again. Alright, so in that expression we have 3 times y plus 9 times x squared equal to 4. And the y is now substituted with 3x minus 2. Again, why do I do this? Because when these two graphs, straight line and something, intersect each other, something, this is definitely a parabola. Okay, but definitely when they intersect each other, the x's are the same, the y's are the same. Expression for y in the straight line can be substituted into the y of the parabola then, because where they intersect, they are equal. That's the whole reason behind it. So your marks will be to isolate the x or the y, to put it into the other one. Now the next mark will be when you've simplified and gotten it into standard form. Alright, now for this one, it's going to be 9x minus 6 plus 9x squared equal to 4. Just distributively simplifying. We've got 9x squared plus 9x minus 10 equal to 0. Are you with me? Then we factorize. If it doesn't factorize,
We use the formula.
you use the formula, and then your answer will be irrational, right? Something
Yes,
with a root.
Doesn't matter.
So be it. It doesn't always have to cut at integer values. It can cut by 1,33 what. And that's why doing it algebraically is so much more accurate than trying to sketch those two and then go figuring out where they intersect each other. This is much more accurate. Alright. So what are the factors?
3x.
Okay, tell me. 3x.
3x
Times
minus
2.
2 and 3x plus 5.
Thank you so much. Alright, if you had to go old school, you actually say 3 times 3 and 2 times 5. Cross multiplication is 6. Cross multiplication is 15. I need to get to plus 9 plus minus minus plus. So it's 3x minus 2, 3x plus 5. If you got the new calculator, it gives you the answers immediately that x was equal to. Now these are the more difficult ones, right? If you need to write 3x minus 2 equals 0, 3x equals 2, and then divide it by 3, perfect. But the quicker you can get to this answer immediately, you'll save some seconds here and there. Or the other one was where x is equal to negative 5 over 3. I'm saying again, if you need to go put the linear equation equal to 0, take the 5 across, divide it by the 3, it's fine. So these two intersect at fraction values, which if you had to read it from a graph, you might not have been that accurate. More accurate to do it algebraically than on a graph, graphically. Am I finished?
No.
Still have to go back, and we always choose the easier one, the linear one. And we've got 3 times x minus 2 is equal to y, or the other value of x. You see, it's like a recipe sum, always. So we substitute with 2 over 3, and we substitute with negative 5 over 3. And the answers work out, please, on a calculator, to 0 and negative 7. And again, I can go write them as coordinate pairs. Say, for instance, they do that. Find the coordinates where these two graphs intersect. Have I finished? So then I need to write it in coordinate form, but that's not always the question. Usually it's just solve for x and y. That was the end of the sum. What does the question say? Solve for x. Right? Previous one was solve for x and y because there were 2 equations. So the moment that you see 2 equations with 2 variables, it's simultaneous equations. Get that into your mind?
Yes.
2 equations with 2 variables, simultaneous equations. 1 equation with one variable, like always. But now this one's got what in it? Fractions. What do we do with that? Because you've done it in grade 10. LCD. Maybe not this difficult. You're going to get the LCD. Because the main thing with fractions are, we don't like them. Shame. How must they feel? But we don't like them, and we can, in an equation, only in an equation, get rid of the fractions.
Yes.
By getting the LCD and timing every one of them with the LCD so that they fall away and there's no more fractions. That's the essence of this lesson. But before I can get the LCD of those denominators, what must I do?
Factorize.
Our old friend, factorization.
Oh, yeah.
5x plus 9 over. I'm going to go quick, guys. So when we factorize them, whichever way you choose, James Bond, calculator, whatever, factorization. This one, must I factorize?
No.
Look at it, please. Yes, remember I want the smallest, the lowest common denominator. So I don't want a 3 minus x and an x minus 3, I want to make them the same. How do I do that? grade 10.
Is a minus.
You time inside the bracket with a negative, which makes this happen, and you time outside. Where outside? Right in the front's the easiest way, so that sign will become a
Plus.
plus. On the right hand side, anything to factorize? No. Just put some brackets around it and you can see your factor. So what is the lowest common denominator for these factors?
X minus 3, x plus 1, x minus 1.
Are you sure this wasn't supposed to be the same? Alright?
Why?
Okay? You check it and you see, okay, because most of the time when you check it, they do intersect each other, they do look the same.
Yeah.
But those are not the same, so that's the LCD. Now I'm going to do it in color so that you can better understand and help yourself with that as well. Remember, do it in a highlight pen. You're not supposed to work in purple and pink and whatever, because that's marking colors. Alright, so when I time with the LCD, because I want you to go finish this for homework for you. Alright, when I time with the LCD, what's going to happen? You're going to time the whole side with it, right? Remember, left side, right side. But the left side multiplied with the LCD is going to imply both of them has to be multiplied. And just the one there. It looks wrong. It looks like I'm doing it twice on the left and only once on the right. But it's because the whole thing is multiplied with the LCD. So here's what you're going to complete for me at home. You're going to have x minus 3, x plus 1, x minus 1 over 1 here. Not enough space. And what's going to happen to it? That's going to fall away. And the plus is going to fall away. What's going to be left?
X minus
X minus 1 times with this whole thing in brackets. No more fractions. Same over here. You're going to have those 3 brackets. Some of them are going to fall away. No more fraction. What is left, you're going to write down here 2x times whatever. Same thing here. You're going to time with all 3 of the brackets. Some will cancel out. The rest is what's left. And then you're going to be sitting with another quadratic equation. So this is your homework. So